Okay, so today I am teaching Danny vector determination and addition. We're going to do two problems. So the top one here, we're gonna add these two forces that are pulling in different directions. So we'll call this one F1, this one F2. So what we have to do to find the resulting vector, this one right here, is, we'll call it FR, is break each of these down and then add them together. So this one's easy because it's straight up and straight over. So if you could visualize like an axis or an x and y axis on my picture here, the F1 of x is 0 newtons because it's not going in the x direction at all.
And all the forces in the y direction.
Correct.
So, yeah.
And the F2 of x is 100 because that's all it's going, is in that direction. F2, F1y is 70 newtons, obviously because if you add those together you're going to get 70 and it's going straight up. And F2 of y is 0. So as you can see, this one's a lot easier because you don't have to consider angles at all. You can just see that this is 100 newtons to the positive y direction, and this one's 70 newtons to the positive, 70 newtons to the positive y and 100 newtons to the positive x. And so the resulting vector will be just, its x coordinate will just be these two added up, and its y coordinate will just be these two added up. So those two added up. Those two added up. And so I guess I should have announced that prior to. What we're looking for here is the magnitude and the direction, this angle of FR. So to find the magnitude of FR, you take the square root of these two numbers. And so the angle, right, is just going to be, you have to use trig. And so we have our, I'm going to redraw this. I'm going to redraw this for us. This is our f of r. Right, this is our y. And this is our x. Our x and our y, I'm sorry. So I just moved this over so you can visualize this trig.
Yeah.
And this is our angle.
Because you could have drawn it the same way if you brought your 100 newtons on the x-axis up on top of your 70.
Right, exactly. And flipped it to make it look like this.
Yeah.
So what we can either use sine or cosine, either one works. It just depends on, we just have to, like if we use sine, we're going to have to do 70 over f of r, and if we do cosine, we do 100 over f of r. But we'll just do sine because it's the regular one. So theta is going to equal, or no, I guess So let me back up. We can use tangent, sine, or cosine,
Yeah.
because we know all three of these now. Since we know the magnitude of this, we can use anything. But if we don't know the magnitude, we have to use tangent.
Yeah.
So let's just say we don't know the magnitude yet, and we're going to use tangent.
Because all that means is you could have done solving for theta first, since you didn't know the magnitude
Right,
of that one.
exactly. You can solve for theta first if you know these two and not that.
Yeah.
Like this. Of 7,400. Once we add those two vectors together, we're going to get that for a magnitude and that for the degree.
Yeah.
And so this one's a little bit harder, number 2. It's a little bit harder because there's angles involved. With this it's just 90 and 0.
You just have to find your components before you can start.
Right, exactly. We're going to find these again, but we have to work to get them. And so I'm going to redraw these again. All right, Danny, you said, I'm assuming you probably like it better to visualize moving this up there.
I can do it either way.
Right, you can do it either, okay.
Stating that you can manipulate the triangles.
I always move the y over here so that I can not have to flip it.
And that way your
You know what I'm saying?
hypotenuse is in like a more stable.
Right, it's on the top, so I like it better that way, but you can do it either way as long as you know how to visualize it.
And then you keep your sides straight, you don't flip your axis. Yeah.
Right. So to find f of x of anything, right, we're talking 1 or 2, you're going to take the magnitude of the hypotenuse, right, times cosine of your angle. Same goes for your y component, except you're going to take the sine of theta. So knowing that, when we do f1 of x, we're going to take 700 times cosine 65. F2 of x. Our f2 of x is going to work the same way, except we have to change our magnitude because it's different.
Yeah.
No. Yes.
Change your magnitude and your angle.
Correct. Okay, so that was these two, we're using this one, and f1y is going to be the sine 65. 2 equals 400 times sine 30. So these two use this one. Okay, so that was the harder part with this compared to this. We had to use these equations to find these 4 components, but from here on it's the same as this part, which that's not so bad. The harder part is this right here. So FR of x is going to be those two numbers added up. Same goes for these. We're just gonna find the FR. We're gonna take the square root of these two numbers squared. And then so the same thing, you can, now that we know the x component, the y component, and the magnitude of our vector, of each of these, we can use cosine, sine, or, right, we can use anything we want. But you can only use tangent if you only know these two. If you don't know the magnitude of our vector.
Yeah.
In this case, we do know the magnitude of our vector. It's right here, but we use tangent.
And you're just using both of the components that you
Correct.
have.
These two components to find out the angle of our resulting vector. So. Right, and so when we take the tangent of this angle, it's going to be the opposite over adjacent. So the
Y over X.
Right, the y over x. Our y is 843.4. Our x is 242.2.
6. Oh, you put 6. You said 2.
Oh, I'm sorry.
Yeah.
642.2. So our theta is so whenever we draw this, the angle is going to be about 52. And it's going to be about 1,060 pounds of force. When you add these two vectors together, they'll equal this. Make sense?
Yeah.